Hey y'all, welcome back. In this video, we're going to be going over a special topic. Now, in APCSA, you don't need to know any of this binary representation or base conversion stuff. However, if you took APCSP with me, you might already know binary, and you might already know zeros and ones and how that relates to decimals. This is mainly a special topic for APCSA. However, if you're in my independent study and you're watching this video and you're going for UIL, or if you're in another class of mine and you're going for UIL, you do need to know this topic, okay? So let's go ahead and get started. I'm going to break this video up into 4 parts: number systems, base conversions, base arithmetic, and 2's complement. This video is going to go over number systems and what is a number system in general. So, number systems. What is a number system? If you Google what is a number system, you'll have this following definition as one of the many entries. A writing system for expressing numbers. That is, a mathematical notation for representing numbers of a given set, using digits or other symbols in a consistent manner. Wow, so that's quite a wordy definition, but let's go ahead and just talk about examples. I think that's the best way to talk about a number system. We all know number system already, and that is the decimal number system. Now, if you look at decimal, it's known as base 10 because decima means 10. So, what are the digits of the decimal number system? Now, let's start at the very first digit. What's the first digit in the decimal number system? If you said 1, close. Okay, you're close. So the first number is a 0. And then it's a 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you're going to notice there are 10 digits. Okay, 0 is the first digit, 1 is the second digit, and 2 is the third digit, and so forth. There are 10 digits in the decimal number system. Decima means 10. Now, let's go ahead and ask this question ourselves. What happens when you run out of digits in your counting? Let's give it a try. So I'm going to start counting. Here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to represent the next number, but I've run out of digits. What do? We start over, right? So we actually start over at 0, and we add 1 to the left, right? Isn't that the next number after 9? And then we keep going. 11, 12, 13, 14. I'm going to start up here. 15, 16, 17, 18, 19, 20. Notice after 19, what did I do? I started over, right? So you're going to notice the ones place always goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 again. You're also going to notice I add 1 to the left side, okay? So that's the decimal number system, where I have 10 digits. Decima, 10, 10 digits. Now, let's go ahead and talk about binary. In binary, it's also known as base 2, and bi means 2. So if for the decimal number system, I have 10 digits because it's base 10, how many values do I have in binary? Well, I have 2 symbols, 2 numbers to represent everything, okay? So I have 0 and 1. Now, let's go ahead and ask ourselves the same question, except instead of what happens when we run out of digits, for binary, it's what happens when you run out of bits. Okay? So, 0, 1. Now what happens? I've run out of bits. you start over, right? Just like decimal number system, you start over. So I have 0 again, and you add 1 to the left. So I can keep going. What's the next value? I've run out of bits. You start over, right? And you add 1 to the left. But I don't have the value of 2, right? 2 doesn't exist in binary. I only have 0 and 1. So what happens? Well, just like in a decimal number system, So what happens when you run out of place values? Well, let's go ahead and give it a try. So I have 0, I have 1. Oh no, I've run out of bits. What do I do? Well, just like the decimal number system, you start over. So I go 0, but I also have to add 1 to the left side. So 1. Keep going, 1, 1. And now, oh no, I've run out of bits. What do? I start over, and then I add 1 to the left. But if I add 1 to 1, that's a 2. I'm in binary. Binary means I have 2 bits, or I have 2 symbols, 0 and 1. So I can't use a 2. So just like in the decimal number system, we have to carry over again. Okay? So I have 0 and 1. Let's go ahead and compare the decimal number system and binary. So in a decimal number system, I'm just going to start counting. We have 0, 1, 2, 3, 4, 5, 6, 7, 8. In the binary number system, we have 0, 1, 1, 0, 1, 1, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0. Okay, so notice how I represent the number 8. It's 1, 0, 0, 0. The number 7 is 1, 1, 1. The number 6 is 1, 1, 0. Let's go ahead and learn about another number system. This one's not used quite as often, but it's base 5. So if decimal base 10 has 10 symbols, and binary base 2 has 2 symbols, how much do you think this one has? Yeah, 5 symbols. And they are 0, 1, 2, 3, 4. Notice there are 5 symbols that we have to represent all numbers with. So, again, I'm going to list the decimal. This one is pretty straightforward. And now quinary, or quinary, however you want to say it, I just say base 5. We have 0, and then we have 1, 2, 3, 4. Oh no, I've run out of base 5 symbols. So what do? I start over, and I add 1 to the left. Keep going. So that's 5, this is 6, this is 7, this is 8, this is 9. And to do 10, I just do 2, 0. That would be 10. Okay. All right. Let's move to the next one. Octal, base 8. So base 8, we have 8 symbols. 0, 1, 2, 3, 4, 5, 6, 7. Decimal, we already know, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Octal, 0, 1, 2, 3, 4, 5, 6, 7. I've used up all 8 of my symbols, so I have to start over. So that'd be 1, 0, and then 1, 1. So notice how you represent the number 8. It's with 10. Do you remember how I represented the number 5 in base 5? Do you know how I represented the number 2 in base 2? What about the number 10 in base 10? Are you seeing a pattern there? Maybe go back in the video and see if you spot the pattern. Finally, our next and last base that we're going to learn is base 16, hexadecimal. So in base 16, we have 16 symbols. Let's go ahead and start listing them out. We have the customary 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But we need 16 symbols. So how do we represent 16 different symbols? These are the values you are familiar with. Well, we start using the alphabet. So 10, 11, 12, 13, 14, 15. Okay, and that is in total 16 different symbols. So let's go ahead and see how decimal and hexadecimal compare. Decimal, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, for a total of 10 symbols. Hexadecimal, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and I'm going to move over to the right, 14, 15, for a total of 16 different symbols. Okay. So in this video, we learn about number systems. We learn how decimal, because it's decima, meaning 10, and base 10, has 10 symbols with which to represent all numbers with. Then we went to binary. Bi means base 2, and we learned how binary has 2 symbols, 0 and 1, to represent all numbers with. We learned about quinary, which is base 5, and we have 5 symbols with which to represent all numbers with. We finally ended with octal and hexadecimal, which both respectively, octal has 8 symbols and hexadecimal has 16 symbols to represent all numbers with. Awesome. So we've kind of branched out from our base 10, our decimal number system, and we're learning about more systems. So we kind of touched upon it in this video, but in the next video, base conversions, we're going to learn how to convert from one base to another base. All right, see you in the next video.